Hey, so we are live now, I bet. So, hello everyone. This is the next, our next Angular Belarus meetup, and it's still a COVID edition since we have a coronavirus, and everybody stayed at home. I hope all of you are staying at home and keep social distancing and so on. And as you noticed, I'm speaking English since it's the first fully English Angular Belarus meetup. And we have two speakers today, and both of them are going to speak English. So just be ready for that, guys. Okay. The first speaker today is Ken. Ken will be talking about Angular language service and what's new in it. Then we'll have a small 5-minute time break to just rest. And then Matt will tell us about NGXS and the power of its selectors. So today we have two full talks. Also, you can post your questions into the comments section. We'll be able to read them and speakers will be able to answer them. So don't hesitate. If you are interested in something, just put it in comments. Cool. Here are links to our community on meetup.com. Here are links to our Twitter, to our Telegram, and to our email. So if you have any questions, just follow us and ask questions, and we will help you. Okay, cool. This Angular Belarus meetups are sponsored by the company called Liau, the company I'm working for. And that's it. Introduction is over, and let's go. So I hope you're ready. And we can start. So Kim, could you please share your screen?
Sure. Let me see. Share my entire screen.
Okay, your screen's here, and we with Matt are leaving, so you can start.
Awesome.
Yeah. Good luck.
Thank you very much, Nick. Hi, everyone. My name is Keen. Today, I'd like to talk a little bit about Angular language service. This is something that I've been working on since I joined the Angular team at Google. I joined the team about 3 years ago, and I've been working on mostly in Angular tooling, which means Angular CLI, language service, a little bit of server-side rendering, a little bit of Blaze as well. Blaze or Bazel, which is the open source build system by Google. So yeah, if you have not seen the Angular language service, then today I would like to showcase some of the features available. It is mostly a VS Code extension, although there are some community members who ported this to other editors, but mostly for first-party support, it is Visual Studio Code. As you can see from the little screenshot here, it does auto-completion and also some definitions and references, which I'll showcase one by one later. So what is the story about Angular language service? It has been around since 2016, actually, but back then, because TypeScript was still in its infancy, so like TypeScript was very new, there wasn't a lot of good tooling, both in TypeScript and in Angular. So we had to figure out kind of like a pretty unique way to make things work in the editor. But since then, like since 2016, a lot has changed, and especially TypeScript itself, it has developed a lot of advanced features and also a very tight integration with Visual Studio Code. So last year, we kind of like decided that, okay, we are going to review how the whole language service was done, and we decided that we are going to sort of revamp it on the foundation level, which means we are going to change the infrastructure, the backend infrastructure on how this works. Because one of the biggest complaints that we have had is like it is very slow. It doesn't work really well with HTML files, especially when you have external templates. So, which is why I decided that, okay, now that we have finally shipped the new version, which was released in version 9 earlier this year, I'm going to do a talk about this. And these are the few features that is supported by the extension. You can hover over a symbol. It will show you some information or maybe even some documentation. You can go to definition, completion, which is very much like IntelliSense, it will show you diagnostics in the editor itself. And also we added, for the latest version, we added syntax highlighting. I'll be going over each of this feature. So a little bit backstory about the language service is that I think this is a really interesting project because it gives developers real-time feedback as they're typing in the code. But in order to make this efficient, it's really hard because Angular, especially the old compiler, which is called View Engine, is not designed for kind of like a real-time use case, which is also why this is one of the reasons we had to go back to our design and revisit a lot of the architectural choices that we made. I'll talk a little bit about what we're going to do in the future, but for now, let's focus on a demo, which I'm going to do on Visual Studio Code. So let's go to an application. This is just a Hello World application that I've created just by running ng-new. Nothing special here. The first thing you would want to do is to download the Angular language service extension. You can go to the extensions tab, search for Angular. It should be the first one. It's called the Angular language service. And from there, you can just download it and restart your editor. With that out of the way, since I'll be using quite a bit of keyboard shortcuts, so I've installed this little extension that would show what I'm typing on at the bottom of the screen. So for example, if I want to see how I can trigger autocomplete, I can go to I can go to Preferences and look for keyboard shortcuts. If you search for trigger, it will tell you that in order to trigger autocomplete, which is trigger suggest, you can either use command. I'm on a Mac, so a command escape or a control space. I'll be using control space. This is just a quick way to figure out what the key bindings are. So let's just try it. I'm going to say control space, and I get autocomplete suggestions. So yeah, this is a stock component generated by Angular CLI. And the first thing I would like to showcase is that if you hover over app component, it tells you it belongs to app module. It says app module.app component. So this is something that is added by Angular language service. I should also add that Angular language service works on top of TypeScript language service. So you get everything that is provided by TypeScript and a little bit more that is specific to Angular. So with that, let's see. For a template URL, this is an external template. If I right-click on the string, I can say go to definition, and it will bring me to a new file. This is another feature that we have added. And let's go to some autocomplete. As soon as I type the angle bracket and I say like app, it knows that there is a custom selector provided by Angular, which is a component on the app root. If we go back to the component, this is the selector. So this is one suggestion that is added to the HTML suggestion list by Angular. And I'm just going to do like a quick example. So first we can create a div. And from here, we can do property binding. As soon as I type a square bracket, these are all the properties available on the div element, and I can pick maybe the class. And here, I'm going to trigger. So what can we bind to the class? We can bind a property from the component to the class field. So I'll trigger autocomplete. I'll say control space. So I can immediately pick title because title is available in the app component. So here I can also right-click on title and say go to definition. It will bring me back to title. Or I can even hover. It will say app component.title, which is of type string. And so I've showed property binding. Now we can move on to like events binding, which is the banana. So as soon as I type that, it knows that these are all the events that I could actually bind to the element. And I'll pick click. So here, if I say on click, it shows an error because onClick is not defined in a component. So this is semantic diagnostics provided by the Angular language service. So now I can go back and add my onClick method. Save this and go back. Okay, the error is gone. All of this is happening in real time. What happens is it's actually invoking the compiler on every change. Well, not on every change. It tries to be smart about that, but it is actually doing a compilation analysis of the component while the user is typing. Yeah. So just one last thing. I've showcased the box, which is property binding, the bracket, which is for events binding. There is also banana in a box binding, but since I don't have any components or directives that provides such a binding, so I'm just not going to use it here, but it is also available. So the other thing that we can see is that even though I'm in an HTML file, this is not just a regular HTML file. It does provide some kind of syntax highlighting. It knows that onClick is a method because Angular language service added a grammar, which basically says it understands all the snippets within an HTML file that belongs to Angular. And that is what powers the syntax highlighting. So I'll show more of it in like an interpolation. If I have this and I say T, it knows that, okay, title is a property that is available. And since if I hover over title, it knows that it is of type string. I can do dot, and I get all the methods on the string. So let's say to uppercase. And from here, if I hover over to uppercase, I get the documentation snippet in the HTML file itself. Let's invoke a pipe. As soon as we type the pipe symbol, it knows that these are all the pipes that are available within this context of an Angular component. I will just say maybe title case. Yeah. So this is pretty much the features that I would like to showcase for now. But before I move on, what I've just shown is an external template. What if we have an internal template? Let me disable this. Without the Angular extension, the inline template is just a string, a raw string. But if I do diff, I do see that there is some syntax highlighting for inline templates as well. This is because we have also added the grammar to TypeScript syntax to recognize inline templates. So you get this out of the box as soon as you install the Angular language service. I can do another interpolation. Say title. Yeah, so we can see that the same kind of syntax highlighting also works for inline template. And this is a feature that is new to version 9. And I think with that is all the features of Angular language service I would like to showcase. Let's jump back to slides. Angular language service is built on top of an open source protocol developed by Microsoft. It is called the Language Server Protocol. This protocol is nice because it means we just have to implement a single server that is responsible for understanding the language, which is the Angular language. And with this server, it can actually talk to multiple editors, regardless of what they are. So we have first-class support for Visual Studio Code, but the community has also adapted this to like Eclipse, Emacs, and Vim. We are working with Visual Studio team, not Visual Studio Code, but Visual Studio, to add Angular language service support there. If you are interested, so say, for example, if your favorite IDE is not available on this list, but you would like to add Angular support to it, I'm really happy to talk to you because it is really easy. I think at most it will take like a day of work because Language Server Protocol LSP really encapsulates all the complexity within the server itself. And all you need to do is write a thin client for the editor. So I mentioned that in version 9, we introduced some new features. We have completely overhauled the architecture for language service. But that is really laying out the foundation for what we're going to provide. Because as I said earlier, right now we are using Vue Engine as the backend. And we realize if we switch it over to Ivy, which is the new compiler, it's going to be a lot more powerful because Ivy does like a real-time translation, almost like an instruction generation for the template into TypeScript code. So we get a lot more powerful features out of that. And one of the biggest features that we have users have been asking is a more consistent diagnostics. Right now, the compiler and the language service, they do similar but different diagnostics checking. But with Ivy, we're gonna whatever the compiler is gonna emit is gonna show right up in the editor. And also with Ivy, we can enable a stricter type checking, which means we are actually type check against the TypeScript code that is generated from the template. There are a lot more features that users have been asking for. So things like code refactoring, find all references, all these nice features that we are familiar with in TypeScript are going to be available once we have integrated with the Ivy compiler. And yeah, this is pretty much it. If you would like to try it out, you can download the extension from the marketplace. Otherwise, if you run into any issues, please file an issue on our GitHub repo. Yeah, that would be all. Thank you very much.
And I'm here again. Okay, thank you, Keen, for your cool presentation.
Thank
I
you.
learned so much about the language service right now. So guys, if you're watching us and have any questions regarding our language service and anything related to it, just feel free, ask questions in comment section. And while you're generating your questions, can I have one question from myself? So what's new for the language service in Angular 10 exactly? Do we have any cool features? So as I know, Angular 10 was just released maybe 20 hours ago, and I'm wondering whether we have any cool features for the language service in Angular 10.
So right now we are mostly focusing on like I mentioned, the next thing that we are going to offer, which is the same language service, but powered by a more advanced engine, which is Ivy. That has been mostly our focus. For version 10, we have mostly focused on making it faster a little bit, and also added some minor features. Yeah, mostly bug fixes because we realized that there are some corner cases where it doesn't work well. So we are mostly focusing on bug fixes. But the new features are really going to come after we have integrated with the Ivy compiler.
Okay, it's cool. Thank you. And here we have a question. So Shakruk is asking, thanks for the talk. A quick question. What about JetBrains products integration?
That is a question that I get a lot. So JetBrains, especially WebStorm, I believe, has its own implementation of language service. So they don't actually use what I've just described, but they do have a very similar experience for JetBrains products.
Okay, cool. So if you guys don't have any questions, okay, if you guys don't have any questions, and thank you, Keen, for your amazing talk.
Thank you.
And yeah, guys, we are going to the very, very small 5-minute just delay between two talks. So don't turn that live stream off. So yeah, bye, Keen.
Right, see you.
I'm removing you. Yeah. Okay, and we are here again. Oh, damn it. Just to my desktop. Okay, so I'm here again, and right now presenting our next speaker. And here's Matt. I'm adding Matt you to the stream. So Matt, could you please share your screen with your presentation?
Yeah, sure.
Okay, I can say, guys, that Matt is learning Russian language right now.
Здравствуйте.
Okay, that's amazing. Thank you. So here's your presentation, and I'm leaving. And Matt, good luck.
Thank you. Okay, guys. So basically, I want to bring a little bit of NGXS for you guys today, and so it's basically a quick introduction how state management looks like with NGXS, and then although I want to show some patterns that I identified working with NGXS to leverage selectors to improve your performance, your code maintainability, and testability. So real quick, funny story, I'm Brazilian. Currently, I'm based in Belgium, but I've been living in Russia since the beginning of the pandemic with my fiance. I got stuck here and has been great. So I also part of the NGXS core team. I'm organizer of NGBE, writer for In-Depth. My company, a company that I work is Reactor in Belgium, and I also coach for Hacker Future, very cool project. Just a brief things that I'm involved. So let's get started. So why NGXS, right? There is a lot of state management solutions out there, and the idea here is not to make a comparison between them or anything. I just would like to show some things that I like in NGXS, and that's why I chose this tool for my state management. So first, it leverages TypeScript decorators to reduce boilerplates, because especially when you're following Redux paradigms, you have a lot of reducers and switch cases. NGXS, nothing of this is needed. It allows you to leverage dependency injection from Angular straight on your state, which is also super cool. So you can extract some of your logic to Angular services. It's progressive, so you actually can start using just the core, which is quite solid, but a small set of features, and then adapt, improve your state with plugins and NGXS labs. And impressive enough, has a quite amazing community. I start trying to answer some questions on Slack channel, and it's very hard because in less than 10 minutes you have 10, 15 answers already. The community is quite active, so you can check the link for the Slack channel on our docs. I'll have a link in the end. So okay, so most of the state managements work more or less the same, but just to review a little bit, for NGXS, we mutate this store with an action, right? So we fire an action, we dispatch an action. This action mutate the store, or communicate with a plugin, or fetch something from the backend, not necessarily only mutating the store. So that's something that's a bit different. And then ideally, you select a slice of the state to use in your component. And again, if you have an event on your component, you dispatch an action, and that closes the cycle. So nothing very specific there, besides the plugins, which I will not cover in this presentation, but there is some very interesting plugins as well. So how can we start using, right? Really simply how we can start using in NGXS in our application. It's interesting to note that NGXS is a state management built towards Angular, to use with Angular, so it's very specific to Angular. So the idea is just npm install NGXS store. Then we need to create a state, and this is quite simple. I have here a very simple model, just like an interface to do with name and completed. And our state is basically a class with a couple decorators, right? Injectable because is a Angular, is the same from Angular, so is a injectable from Angular. And we have this other decorator here, state, where we pass the type of state. In this case is a to-do array. The name, which is going to be the slice, the name of the slice of the state, and some defaults optionally. In this case, I'm just passing an empty array, right? With this, we just have to add the model to our root model of our application. So NGXS model for root, passing the to-do state. And I like to enable development modes when I'm not in production, because this freezes all our states, so forces us to keep everything immutable. So it's quite cool. So with this, we already have a state running. But a state is no good if you cannot change anything on the state. So let's talk a little bit about actions, how actions look. So actions in NGXS, they are classes, because in order to remove the need of having switch cases, which are actions, we use reflection. So that's why our actions are classes. There is a nice trick here, which is I wrap my exports in a namespace, so I can easily just import the to-do actions .load or .add when I dispatch my action. So basically, this is a simple action without a payload. I just have a static type with a string, which is my action definition. This is the same text that's going to show in the Redux DevTools. Or if I have an action like add to do that I need to have a payload, I just have to pass as a property in my constructor, and that will be the payload passed to the action. Okay, so with this, how we handle these actions. So if you don't have these reducers, how I say what I want to do when I receive this action. Actually, inside our state is quite simple. We're going to use another decorator from NGXS, which is the action, add action. And I just have to pass to this decorator my action. So you can see here that I'm using to-do actions.add to do. And this is going to, and the following function, in this case, complete to do, is going to basically be the callback that's going to be called when it send this action, right? So my first argument is going to be context, which has get state, set state, dispatch, and batch state. And the second argument is going to be an instance of my action. So I can spread here, in this case, the name of the to-do, and then I can add the to-do by setting the state, right? Another interesting thing that you can do in NGXS, since you have dependency injection, you can basically inject your service here and have an asynchronous action. So you basically just return observable, in this case, load to-dos, and you can pipe, and in a tap operator, you can set your state. You don't need to subscribe in this case, because the framework is going to take care of all the RxJX subscription and unsubscribe when needed. So that's how you register your handlers. You can even have more than one handler per action. This is not a limitation. So, okay, so now we have handlers, we have the actions. So how do we dispatch actions? Quite simple as well. In our component, in this case, to-do component, we can inject the private, the store as private, and then just do this.store.dispatch. And you can see here that the action, since the action is a class, I'm creating a new instance here to do actions.load to do. Or if it's an action with a payload, I can pass the payload in the constructor of the action. And that's it. That's actions in NGXS. Quite simple, right? And then now we have a state. We can change the state, but I still want to read something from the state, right? So there is a simple way of doing it, and then I'm going to show the way that I like to do it, right? So the simple way is really, we can use a select decorator and pass a function that's going to slice your state. You can see here that to-dos is the same name that I gave in my to-do decorator back then. And then this is going to provide me an observable of to-do array. Or I can inject the store again and just do this.store.select. And this is going to be observable. I can just pipe and do something else. In this case, I'm creating a completed string, which returns me just the completed to-dos, right? So the problem with this is that I'm adding a lot of by map and some RxJS decorators here, operators here, and that's not exactly what I want. So ideally, I can leverage another thing from NGXS, which is selectors, right? So selectors, basically, I define a function, a memoized function that tells me how to slice the states. And then my component uses the selector and doesn't need to know exactly the structure of my state. So the selector kind of acts as a facade between the states and actually the consumer. So how this works, for instance, I can create inside my state class a selector. In this case, get completed. I'm just redoing the example of before. And here, the first argument is going to be my state. So I can do state.filter, and I have my completed string. And then in the component, I can use my decorator select to get the completed, or I can inject the store and do store.select to use the selector as well. So this is NGXS in a nutshell, right? There is a bonus tip that I would like to show here, which is state operators. So when we talk about state management, we want to keep it the transformation that we do in the state immutable, right? We don't want to mutate our state. And sometimes this brings a lot of code and makes not so readable or quite cumbersome. That's why NGXS has state operators, which allows you to very easily change your state in an immutable way, right? These are the operators that we have now. You can even create your custom ones. And I have a small example here. For instance, that complete to-do action, if I use, I would have to take the to-do filter and then set the whole state back, and would be very cumbersome. In this case, I just have to do really update item is one of the state operators, pass the ID, and then I just patch this, the item with this ID with completed true. So it's a very interesting way of doing this. You can compose them. You could even create your own operators. And the cool thing is that these NGXS operators, they are not only limited to state modifications. You can use anywhere in your code. They're very, very cool. So this was the basics of NGXS, really like a rough introduction. And what I really want to talk is how we can leverage selectors. But for this, a to-do app will not do, right? So I was thinking about a nice example to demonstrate some of these features for you guys. And since all this pandemic thing, staying at home, social isolation, I started cooking a lot, right? So I decided to do a recipe app, because the nightmare of someone that cooks every day in the week is to build a shopping list, right? So that's what I did here. I built a recipe app that I have my recipes, and I can filter by breakfast, lunch, dinner. And if I pick a couple of these recipes, I can see a counter here. And I can even see my shopping list. I take notes of this, go to the market and I buy these things, and I have everything that I need for the whole week, right? Super simple app, but it's interesting enough for us to show some of these things that I want to show about selectors while we implement a couple of these features that I just demonstrated here. So let's real quick just see our model for this app. It's quite simple. We have a recipe state model. which is going to be our state, is basically a recipe array and array of IDs of the selected recipes. And I also have some accessory types here, just what's a recipe, what's an ingredient, and the recipe type. So first, before we do this, when we're working with selectors, there is some tuning that we can do in NGXS to take the most of selectors, right? So this is an example how we implement selectors like I showed before. So in this case, I'm taking recipes and selected recipes. So you see that selectors are inside the state class. We can improve this a little bit, right? So the first step that I would take is to adjust the selector options. So when we inject our NGXS models, we can adjust two options for selectors in NGXS. The first one is suppress errors false, and this basically makes all the errors that are generated inside your selectors to be logged in the console. If this flag is default true, and if you don't set it to false, any error in your selector is going to silently fail and emit undefined. So that's not what we want when we're using heavily selectors. So putting this to false will allow you to debug better your selectors. And also inject container state false, you eliminate this first argument as the state. So what this does, it gives you more control in what are the arguments of your selector, right? Because sometimes if you start composing selectors, you don't want all your selectors to reload when you change your state, right? Some selectors will not rely on the state, it will rely only on other selectors, right? These two options going to be default false in the next release of NGXS, but for now we have to tune them to false. So with this, since we don't have the container state injected anymore, we have to update our selectors. So we just have to inject the state here to have the same selectors working as before. And another thing that I like to do is, because with time, you start to have selectors and action handlers inside your state, and this file can easily grow beyond readability, human readability, right? So what I like to do is to extract these selectors. Since I don't need the container state anymore, I'd like to extract to its own class, right? So this is quite simple. I just have to create a class, and my selector is basically going to be static functions inside this class. And then when I have to use, I can just import this parent class dot recipes, for instance, to use my selector. Another important thing on this approach is that these functions are just pure functions with no Angular context whatsoever. So they are extremely testable. It's very easy to mock the inputs of this function and test them without even the need of a test bed or Angular model or anything like that. So just a takeaway from this section, adjust your selector options, enable selector errors, control better your dependencies, and extract your selectors to their own class, because they're going to be easier to test, and you also have a better separation of concerns. Each thing, the selectors have their own file. If you have to change something in your selectors, you know where to find them. So let's start implementing some of that features, and then I can show some ways that I like to use selectors, right? So the first one that we're going to implement is this shopping list count that counts how many recipes we have selected. So for that, we could have a very naive approach and just, okay, now I know how to use selectors. Let's create a selector here. And the selector basically takes the state, selected recipes dot length, and I'll have the number of recipes that are selected, right? What's the problem with this approach? I'm using my dependency is the state. So whenever something changes in the state, this selector is going to recalculate. And in this case, I just have a very simple code. But if I had a more complex code, this would be running even if selected recipes, which is important for the only thing important for me, it doesn't change, right? Because I depend on the state. So that's what I mean by controlling better your dependencies. How we can solve this is very simple. We can compose selectors. So I already have a selector for selected recipes that's going to meet only when the selected recipes change. And I can use as an input for my selected count, right? So I just import it here. And then I can use my first argument is going to be the result of that selector, and I return the length. With this, even if I change any other slice of the state, this selector will be recalculated only when needed, indeed. And then we can just use in the OR component like it was shown before. So takeaways of this: compose your selectors, recalculate only when, because then they're going to recalculate only when needed, and also reduce code repetition. You don't want all your selects to know how to slice your state. You can just reuse code from other selectors, right? Okay, next feature. The next one is this shopping list, right? So every time I add my recipes, eventually I want to view my shopping list, and I want to take all the ingredients of all the recipes, sum them if they are the same, and build a shopping list. Our initial approach would be very simple. First, this is not very important what this code does. I just wanted to show that for this simple feature, we can have a quite not nice code. Like I'm using some object.keys, I'm using some reduce. So I don't want this code to run multiple times, right? In my case, I have very few recipes, but if let's say that this app grows and I have like thousands of recipes, I don't want this to be running all the time. So there is a way to improve this. So let's see a little bit how we can improve this idea, right? So our initial approach would be something like this. I select my recipes selector, I select my selected recipes selector, and then I can do a combine latest recipes and recipe selected. And then I pipe on this, receiving the emission from both observables, and then I can apply that function that I showed before. What's the problem here? First, I have to know a lot of RxJX here already, right? Combine latest, map, and might seem very simple for someone that's experienced with RxJX, but for a newcomer or a new developer, this can become very cumbersome. Do I use combine latest, merge map, concat map? What should I do, right? So there is a very simple way to do this differently. So we can just move all this logic to selectors, right? Because in my selectors, I'm not dealing with streams. I'm dealing with synchronous data. And my selector is going to be recalculated automatically by NGXS, right? So basically, I can inject here recipes and selected recipes, and then just apply the function on them. So when I use my shopping list selector, everything is already packed the way I need in the view, right? So takeaways from here: move your business logic to selectors. I like to see the selectors as the house for business logic, because then you don't leak your business logic to your components. If you have multiple components using your state and you decide to refactor your business logic, you can refactor your selectors. And if you keep the same contract, you don't even have to touch your components. So you keep your presentational components dump, you improve your maintainability because, yeah, you know where to change something. And if you keep the contract, you have way less refactor to do, and reduce the need of manipulating streams. So the less RxJX, the easier the code is to reason for new developers and things like this. Last feature is filter by type, right? Here also I can choose which type of recipe I have. And our initial approach would be something very simple. So basically I add the filter to my state. So this, I'm showing here just the selector, but to add the filter to the state, I have to create an add filter action, dispatch this action whenever the user selects the filter and all these things, an action handler. Here I'm just showing the selector, but all this would be needed behind. And then I'll combine these two recipes and filter, and I can filter my recipes based on the filter value, right? The problem here is the filter is something really reliant on this recipes list component, right? It's a local state of this component. I don't want to put, if I put all the local state on my global state will easily become very crowded. So the idea is to keep the state of this presentation component inside the presentation component. So how can we do this? We could use a lazy selector. So in NGXS, we have this concept of a lazy selector, which consists in a regular selector that returns a function. So basically, I inject my state selectors.recipes, and then I can return a function, which takes a filter, and I return inside this function my filtering logic. So when I select this selector, I'm going to get actually a function that receives a filter and returns me an array of recipes. It's interesting to notice that not only the selector is memoized in this case, but also the inner functions. So this guarantees me that I'm only going to run this once per tab on my filter, because the next time I request the same filter type, this answer is going to be memoized. So in the component, I could just select my function here, which is get recipes by type func, and I can keep the filter inside my component. It doesn't exist in the state. The state doesn't need to know about this filter. This can be a completely local field. And then in my template, I just have a small HTML here to select the filter, really just setting the filter variable in the component. And then I can unwrap my function using ng container. And then in my ng4, I'm just going to use this function with my filter. So I always going to list my recipes depending on the filter that I selected, without my state even knowing about the filter, right? So a takeaway here, leverage lazy selectors, because then you're going to just run the code when needed. So if my user stays on the all tab, there's no reason for me to filter in the other cases, right? Only if the user actually goes there. Avoid running the same code twice, because the inner function is also memoized. And you keep your state lean. You only put in the state what actually needs to be shared between multiple components, not local state of components. There is a bonus tip here, because who never worked with NGXS, this might be very cool. You can use the Redux DevTools with NGXS, and it's super, super easy. You basically have to install NGXS DevTools plugin, and then you have to add the NGXS Redux DevTools plugin here. I also like to disable when I'm not in production mode, right? So when I'm in production mode, because I don't want my end user fiddling with my store if he has the extension, right? So just a quick recap before I go of some takeaways that I think is interesting from this presentation. Use TypeScript namespace for your actions. This is in general, not only with NGXS, but namespace from TypeScript, they are very, very cool. And for actions, I think they are well suited. use state operators to make your state changes based on immutability in a very readable way. Leverage them, create custom, compose them, adjust your selector options to take the best of selectors in NGXS. Structure selectors to their own class, so you can have a separation concern there. Compose your selectors to avoid code repetition and your selectors recalculating when you don't want. Move your business logic to selectors. Yeah, less RxJX black magic happening. And leverage relay selectors to possibly improve a lot your performance. That's all. I'm going to leave the quick link here because I know that the audience is mostly Russian speakers. There is a talk from Max Ivanov on Angular Minsk in Russian. Very, very cool. He basically compiles and compare NGRX, NGXS, and Akita. So check it out. And also if you like this idea of using NGXS, head to our docs, ngxs.io. Everything is really well explained there, and there you can also find the link to our Slack channel, the community. If you have a question, just post there, or reach out to me on Twitter. Thank you.
Okay, cool. Thank you, Matt, for your amazing talk. And guys, it's like the same time when you can start posting your questions about NGXS and NGXS selectors especially. And well, just we have no exact questions at the comment section. I have one very important for me question, Matt. So I just want to hear your opinion. Yep. In what situations it's better to use NGXS over NGRX? Oh, yeah, over NGRX. Since I'm using really overusing it in my projects, and I'm wondering, what do you think about it? When it's better to use NGXS?
So I'm not a super expert on NGRX, to be honest. I've been working with NGXS for a while because matched my coding style. So I really think there is almost all the features on both of them. I just really think it's pick your flavor. Is really which kind of code you like writing and how you like to write, right? For me, NGXS has less boilerplate and has a different approach, a bit more close to CQRS, which I really appreciate. So I really believe is pick your flavor on this. That both tools are able to deliver really high quality software. In my case, I really like the approach of NGXS. That's why I've been working with this for quite a while.
Okay, I got your answer. Just when I was watching your presentation, I just wondered that NGXS really looks like NGRX, but with a smaller code or something like that.
Yeah. This might be the first impression of a lot of people. We also have quite big commitment with extensibility, so it's very easy to build your own plugin for NGXS, and we have quite interesting plugins. It's quite, and we also so we have a quite nice API for you to create a plugin and hook into the NGXS engine. So I think this is also something very interesting on NGXS.
Yeah, sounds interesting. I'll give it a try. Okay, and here we have a few questions. So, question from Sanders. So, since NGXS is using tons of decorators, does it impact the bundle size or any other performance impact? Or did you measure that?
No, so I'm not a super expert on that, but I don't see any impact since we are using TypeScript, the decorators, and in the end, this code is compiled to JavaScript, and this is going to be removed. We're not packing any compiler together with NGXS. So yeah, I understand from where your question is coming from, Santos. But no, there is no, at least not no critical impact on performance as far as I'm concerned. But yeah, very. I think more information could be investigated, but initially no.
Okay, cool. I hope you're right, and NGXS is a super performant library. Okay, guys, do you have any more questions here? Or maybe I don't see them. Okay, comments, but very few questions. Okay, cool. Since we have no more questions, I think that's all for today. Big thanks you, Matt. Your talk was amazing. I really like it. And after your talk, I decided to try NGXS.
Oh, thank you. Let me know if anyone has questions or, later when you decide to try. I'm also going to tweet tagging Angular Belarus my slides and the demo that I showed. So if you want to just work and play a little bit, you could.
Sure. Cool. So, yep. Thank you, Matt. Thank you, everyone, for attending that meetup. And that's it for today. So, guys, we are ending the broadcast. Yeah. So, guys, bye.